Hello everyone. In this video, we're going to be simplifying, not solving, simplifying a radical expression, a very radical expression because of the double radicals. We have 2 minus the square root of 2 minus the square root of 3 all over 2 plus the square root of 2 minus the square root of 3. What is the square root of 2? 1.4 something. Square root of 3 is 1.7 something, but we're not estimating here. We're not doing numerical calculations. We're actually going to do this the algebraic way. Okay? Now, how do you simplify a problem like this? Well, there's a couple of ways to go about it. I'm going to show you both methods, even though one of the methods you're probably not going to like that much. Let me know what you think at the end. Also, make sure to check out my other channel, which is called aplusbi. That's how you write a complex number, right? Hopefully you remember that. Check it out and let me know what you think. I also have a shorts channel, publish once a week. I know it's very little, but hey, I'm busy, work full time. This is kind of like a thing that I do in my spare time, which is something that I enjoy so that I get to, do math, okay, and share with the public. So, how do we simplify something like this? First method, we're going to use, what kind of expression do you think we're going to get at the end, right? So when you simplify something like this, are you going to be getting root 2, root 3, anything else? So here's my guess. And again, this is just totally a guess, but we can verify that at the end if we have the patience and the time. So we're going to get, obviously, some number, right, an integer. So let's call that a. And then we're going to have some root 2, obviously, because root 2 is multiplied by root 2 to produce integers. And then root 2 and integers make root 2s and so on and so forth. You see, to be able to get all these terms, we're going to assume something like this, but that's not good enough because I still need to include root 3. And there's a chance that I might need root 6. I'm not sure about that completely, but I'm just going to make a guess and say that just to be on the safe side, hey, I think we're going to have some terms like this too, root 6. And that just comes from the very fact that root 2 times root 3 is equal to root 6. Does that make sense? And when I say root 2, I mean the square root of 2. Instead of saying that, I just want to say root 2, which is faster. Some people say rad 2, some people say radical 2, whatever, however radical you are, you can say anything you want. Okay, so what is the next step? This is the worst part. Trust me, this is really bad. Cross multiplication. And it's going to get super, super messy. Okay? Not the soccer player messy. Like messy, okay? So it's basically going to entail multiplying these two things and then setting it equal to this guy over here. Such a simple guy, right? Now let's go ahead and see how we can do this. And I want to write the variable piece first. You know why? Because I kind of want my system of equations. And yes, this is going to turn into a ginormous system, which you're probably not going to like, but who knows? Some people like busy work. Okay, great. So now we're going to go ahead and distribute this. And when we do, we're going to get a lot of terms, like I said earlier. For example, this gives us 2a. And just do it, like with patience, 4 times 3, 12. You're going to have 12 terms. That's a lot of terms. And then we're going to combine like terms. Am I speaking too fast? I don't think so. When I do speak normal, people say, oh, you're too fast, we can't follow up. Well, you can always slow it down. Did you know that YouTube has some features like 0.75, 0.5? Yes, some people speak really slow. And what I do is I would do 1.25, even 1.5 if I can catch up with that. So you can do any speed you want, okay? So now 2a, and then you're going to do a root 2. And write the radicals last, like because a is an integer. Oh, by the way, I forgot to tell you. Sorry about that. A, B, C, D are integers, okay? They could also be rational numbers. There is a chance, but I doubt it. Anyways, let's just say rational numbers because integers are rationals, right? And then the next thing is going to be minus a root 3. Great. We're done 1/4 of 2a. Good job. Now you get 2b root 2. 2b or not 2b. Sorry, I had to make that joke. And then we get b root 2 times root 2, which is 2b. Again, 2b or not 2b. Minus b. Now, when you multiply these two things, you get what? Minus b root 6. You see, this is where the root 6 comes in. And it's probably going to work. Now, instead of just, continuing on the same line, what I want to do is I want to take this guy and distribute it, but I want to write it on the next line because it's going to be easier. And line up the like terms. For example, b root 2 times 2 is 2b root 2. I think it goes here, right? And then multiply b root 2 times root 2, which is 2b to be or not to be, that comes up again. Wait a minute, how did we get that first time? Oh, wait a minute, probably messed up somewhere. Okay, I distributed the A, and then I started doing the B. Yeah, that's right. No, I did the B already, never mind, sorry, I'm repeating myself. Okay, A and B are done. Now we're going to do this one. Never mind, I messed up. This is C, 2C root 3, so it's gonna go here, right? And then with this one, C root 6, so it's gonna go here. And then finally, minus 3C, and minus 3C is gonna go here. Of course, this is a plus sign, by the way, there's nothing. And of course, everything will be collected at the end, okay? Now this one is done too, so it's not super bad. We have 9 terms so far, and this is the last one. 2D root 6, right? 2D root 6 goes here. And then, okay, this is the critical part. D root 6 times root 2. Root 6 times root 3 is root 12, which is 2 root 3. So that's going to be 2D root 3. 2D root 3. And then finally, minus D root 18, sorry. 6 times 3, right? Like this. And root 18 is 3 root 2. So this is going to be 3D root 2, but with a minus sign. Minus 3D root 2. Okay. You see how I align these terms? This is going to help you a lot. Root 3s, root 2s, integers, and root 6s. And of course, there's more root 2 here and integer here, but that's okay. We can always just put them all together. And if you want, you can bring the 2a here so that you can add the whole column. And then a root 2 will go here. And of course, this is a plus sign. That's a plus sign. So we're all good now. Notice that this is a minus sign. You have to keep it. It's always to the left, right? Great. Now let's go ahead and put it all together. It shouldn't be super bad. And I want to start with the integers. 2a plus 2b minus 3c. That's the integer part, right? And then I will do the root 2. A plus 2b minus 3d. There's no c root 2, by the way. And there's a good reason behind that, right? Because c has a root 3 attached, so it won't produce root 2. And then this is root 2. And I'll go to root 3 here. That's going to be plus 2c plus 2d minus a, root 3. And finally, we're going to do the root 6. We've done that. We've done that. It's going to be c plus 2d. Can I write it here? C plus 2d minus b, all multiplied by root 6. Beautiful. Now this is equal to what? 2 minus root 2 minus root 3. You know what that means? We don't have a root 6. I mean, we do, but we don't. What does that mean? It means the coefficient of root 6 is supposed to be 0. That's, again, an important piece of information because you can do this with and without and see what happens, okay? Now, what is next? The integer must be a 2. Coefficient of root 2 is -1. And this guy over here, the root 3, the coefficient is -1 again. So you get a system of equations with 4 variables. Good job. Solve it, matrices, whatever you use. And that should give you the values of A, B, and C, and D probably. And hopefully you can do that. But I'm too lazy. I'm going to leave it as an exercise for the reader. Please do not hate me for that. Okay? Here we go. Here's the second method, which is kind of my favorite. Okay? But again, it's totally up to you. Now, what was the expression again? I forgot. 2 minus root 2 minus root 3 divided by 2 plus root 2 minus root 3. Let me double check. Minus, minus, plus, minus. Yep, that's right. So now, instead of doing the longer way, we could probably do it shorter. Well, not necessarily shorter, but this seems to be a little safer, at least for my perspective. You get to decide. I'm going to take it as a whole and multiply by the radical conjugate. In other words, if I multiply this guy by that, some radicals, right, will disappear, hopefully. And I don't need parentheses. I just wanted to emphasize the fact that this is A and that's B. We're kind of multiplying A plus B and A minus B, which is from difference of 2 squares, A squared minus B squared. Make sense? So here's what we're going to get from here. And you don't have to distribute right away if you don't want. But at the end, you will have to. And not too bad. At least if you don't have any variables. Now, when you multiply these two things, you're going to get something like this. Okay? Square root of 3 squared is 3. Now, if you expand this, you're going to get 4 plus 2 plus 4 root 2. minus 3. That's going to give you 6 minus 3, 3 plus 4 root 2. That's our denominator. It's okay. And what we're going to do is we're going to multiply by one more time. So let's go ahead and distribute the numerator. Let's see what we get. And then we're just going to put this in the denominator right here. So we're going to get 2 times 2, 4, plus 2 root 2, plus 2 root 3. This should be easy. Minus 2 root 2, minus 2, minus root 6, minus 2 root 3, minus root 6, minus 3. Great. And then all over the denominator is 3 plus 4 root 2. We're going to have to do this again, but wait until we simplify the numerator. Okay? Cool. Now let's go ahead and combine like terms. 4 minus 2 is 2. 2 minus 3 is negative 1. Okay, so we're going to have a negative 1 here. We've done those. Now let's do root 2's next. These two cancel out. So we have no root 2 left yet. And now root 3 is going to, they cancel out as well. This is weird. Minus 2 root 6 divided by 3 plus 4 root 2. Awesome. Simpler the better, right? Now we're going to go ahead and multiply by the conjugate again. This time it's 3 minus 4 root 2. You can also reverse it, but I don't know. No big deal, I guess. We're going to take care of that at the end. There's going to be a lot of negatives, so we're going to have to negate both the numerator and the denominator. But let's go ahead and distribute here. That's a negative 3. And then we get plus 4 root 2. And then minus 6 root 6. And then plus 2 times 4 is 8. Root 6 times root 2. So it's kind of like 8 root 12. But root 12 is 2 root 3, remember? That gives you 16 root 3 with a plus sign because they're both negative. Make sense? And then all of that is divided by 3 squared minus 4 root 2 squared. 4 root 2 squared is 16 times 2, which is 32. Awesome. And now what are we going to do? We're going to go ahead and simplify this a little bit, but it can't be simplified. Okay, we're going to write it like this. Negative 3 plus 4 root 2 plus 16 root 3. I just want to write it from smallest to largest in terms of radicals. Divided by 9 minus 32, which is negative 23, right? But since I can negate the numerator and the denominator, it's going to give me this number at the end, which means we are supposed to have, oops, that's supposed to be a plus sign. Make sure to change everything. It means that we're supposed to have root 6. So when you go back to the first method, here you're going to find values for A, B, C, and D. They're all going to be non-zero, which means if you assume there was no root 6, you would get it wrong. Now, you can go ahead and separate this into pieces like this if you want. It's not super important, but this would allow you to compare with the first method, because the first method basically depends on A plus B root 2 plus C root 3 plus D root 6. As you can see, the values of A, B, C, D are going to be obvious, hopefully, from here. And this brings us to the end of this video. Well, thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care. Don't forget to check out SyberMath and aplusbi and the Shorts channel. And bye-bye.